So here we are, both patterns are ready and we're going to vacuum form a mould. Let me just tell you a little bit about vacuum forming. You'll see how simple it is, just a vacuum cleaner rigged up to a little box that creates a vacuum. A lot of people think that the vacuum cleaner actually sucks the plastic down over the mould. It's not really true. What it does is create a vacuum and the atmospheric pressure just goes thump and pushes it around whatever shape you have here. Simple and effective. Now, because the plastic needs heating up, we have a little oven here. You'll see you wouldn't get much simpler in terms of an oven. You might be using a bigger one, and you can even make bigger formers in a bigger box if you like. One of the things that the oven must have, of course, is a clear door, because we need to watch what's going on. Okay, you have a forming frame and a sheet of clear plastic. In the Plasform kit you have two sorts of plastic sheet. One is the clear plastic for vacuum forming, for moulds, especially if you're going to cast it in liquid plastic. And the other sheet, the white styrene, is used either for making a product or it might be used for a mould, but not for the resin. It's a mould suitable for the concrete. It's a little bit stiffer and it holds together with the weight of the concrete that you're pouring in it. Right, you can see that. You'll notice that the masking tape goes half on the sheet plastic and half on the forming frame. It needs to be pressed down firmly all the way around, and you'll also notice that these forming frames have a smooth side and a rough side, and you've put the tape on the smooth side. Simple enough. Now, you won't really see what's happening in the oven, so I'll explain it to you before I do it. What happens? The plastic goes in the oven, the heat softens the plastic, and the molecules in here actually have a memory. And once the heat is applied, they start waking up, say, hey, what was it like before we were flattened like this? And then they start to move around a bit, and all of a sudden they get excited. It's time to wake up, folks, let's go. And all sorts of things are happening. So as soon as you put it in the oven, you'll see this movement of the molecules going all the way across. And if you're not careful, you think, hey, it's nice and soft, it's ready to form, but it isn't. You leave it there a little bit longer till the molecules have a little bit of a sort out. The masking tape stops them from moving away too much, and then they just soften. So the sequence is that it ripples, it looks as though it's soft, but it isn't. Then it goes all tight, and then a minute or so it then starts to sag, and it's at that point when this plastic is starting to sag a little bit that it's right ready to do. Now, I won't be able to say anything when I'm doing it because the vacuum cleaner will be too noisy, but what I'm going to do is bring it out of the oven, and I have to get from the oven onto here fairly quickly because it's cooling in the air. But I do something with it. I bring it out of the oven and I turn it over so that the masking tape is downwards on the former. I put it down here and the atmospheric pressure then just pushes this sheet plastic all the way around over our little former. Okay, so remember, in the oven, brought out, turned over and put on all fairly quickly. If you don't do that, and you can try it if you like, bring it straight out and put it on, and probably when you put it down here the plastic will push off the masking tape. So it's better to turn it over, put it on. Now all you have to do is create a vacuum and the atmospheric pressure pushes it around. Okay, enough talking, now let's see some action. In the oven, I better put the gloves on so I don't burn my fingers, but it really doesn't get hot enough to create a problem like that. What did I do with my gloves? Oh, there we go. Now I'm watching closely just to see when it's ready to bring out and form. And as soon as I see that it's ready, I will flick the vacuum cleaner on and you just watch what's happening. You can see why we need an oven with a glass door. You need to be able to see what's happening. And if your oven has a light on, it'll be that much easier to just see, especially with the transparent plastic. It's just a little bit hard to see what's happening. You'll notice the oven, well, probably you can't see, but I'm telling you, it's about 400 degrees Fahrenheit. This is an old oven. I don't know what that is in Celsius. But anyway, whatever it is, we're ready to go. On with the vacuum. Right, it looks like the patterns are actually stuck there, but they're just sitting there and they can come out and we can use them again because we'll need to make more than one former. And there we have, look at it this side, we have a nice little vacuum formed mould in which to make our cast plastic girder. Right, the next little project we're going to work on is very similar to the girder construction. We make up a pattern, we vacuum form a mould over the pattern, and then in the mould we cast, in this case, a lightweight concrete mixture. Remember, we're making a series of panels that we're going to join together to make a freeway noise barrier, such as we have here. Now we can use clay, which I'm about to shape in the shape of a freeway barrier of some kind, or you could use medium density fiberboard, cut out your pattern with a Stanley knife and then just scrape out the middle. Remember, this is just like fancy cardboard, so it's fairly simple to use. Or if you want to get a shape with a little bit more contrast as far as height and depth, you might want to use clay. This particular pattern is going to be made fairly quickly because we can't keep our video cameraman here all day while I fiddle around with some clay. So I'm only going to make a small module. You can see that clay is rather easy to use. Right, I can shape it. Now remember that the design brief calls for a pattern that will join from one module to the next, and you will probably see that I've bypassed a very important stage, and that is designing the product in the first place. All I'm doing now is giving you a bit of an idea of how the pattern is actually made in clay. Right, join up some pieces here, cut off the edges. Now I won't be able to form this because as soon as the heated plastic goes over, it'll probably squash because it's still a little bit too wet. But you get the idea that if I wanted to make up a barrier fairly simply, I make the pattern in clay, work it around the edges, and there we have it. Now I wouldn't vacuum form that because it really hasn't been finished enough, and that's one thing you need to remember about making the pattern, is that because it's identical to what the finished product will be, we need to be a little bit careful that we just get it right. If it's left with a finger mark in the side, every panel you make will have that same finger mark in. So it's better to fix it at this stage and then you don't have any more problems. Get it right in the first place. If you read your notes, you'll notice that when the little Japanese man made up the pattern for an instrument housing on the 1978 Nissan Skyline, he spelled housing H-O-W-S-I-N-G. Only a simple spelling error, except it's been duplicated hundreds of thousands of times. So it's better to fix it at this stage rather than reproducing it with every one you make. Now we have our pattern already made. This is not in clay, this is actually lightweight concrete, but the clay is still a little bit too soft to form. But you can see the original made in clay was exactly the same shape as this one. So we're able to use this now as a pattern over which we vacuum form a mould so that we can make more concrete panels. And just to show that the vacuum forming that we did before wasn't a fluke, we'll go ahead and do it again. This time, instead of using the clear plastic, we're going to use the white polystyrene. Exactly the same as a margarine container. Very good for forming. Into the oven. Same process as before, only you will notice that the styrene will soften that little bit quicker than the clear PVC. So we need to watch it fairly closely. Seeing it's going through the ripply stages now, molecules trying to remember where they were. Then it all goes tight, and then a few more seconds and it starts to sag. You notice a couple of jam tins in the oven. They're just put in there to lift the frame up clear of the wire. Otherwise, when the plastic starts to sag, as soon as it touches the hot wire, it will put a hole in the plastic. A couple of jam tins, just fine to lift it clear of the oven tray. I can see it's starting to sag now. On with the vacuum cleaner. See the jam tins in there? Just right. Now, how did our little product go? You can see it wasn't a fluke first time around, couldn't you? A few taps there. Incidentally, if this was clay, you'd have to be very careful getting it out, because you probably want to make more than one mould. So you have to take your time just getting it out. Careful that you don't break the clay. And you can put it back on the former. I might have to take the gloves off so I can touch it. Very carefully take the pattern out. Here we have it. Back on the mould. Another sheet of plastic on the former, and exactly the same process. Right?